Hello guys, today we're going to talk about the PN junction diode. Hundreds of different electronic devices have been produced since the invention of the solid-state components. Solid-state devices are made by combining P-type and N-type material. The device produced is determined by the number of layers of material used. The thickness of the layer of the material and the manner in which the layers are joined together. The diode operates like an electric check valve, in that it allows current to flow through it in only one direction. If the diode is to conduct current, it must be forward biased. The diode is forward biased only when a positive voltage is connected to the anode and a negative voltage is connected to the cathode. If the diode is reverse biased, the negative voltage connected to the anode and the positive voltage connected to the cathode, it will act like an open switch and no current will flow through the device. When working with solid-state circuits, it is important to realize that circuits are often explained assuming conventional current flow as opposed to electron flow. The conventional current flow theory assumes that current flows from positive to negative, while the electron flow theory states that current flows from negative to positive. Although it has been known for many years that current flows from negative to positive, many electronic circuit explanations assume a positive to negative current flow. There are several reasons for this assumption. One reason is that ground is generally negative, and it's considered to be a 0 volt in an electronic circuit. Any voltage above it or greater than ground is positive. Most people find it easier to think of something flowing downhill or from some point above to some point below. Another reason is that all of the arrows in an electronic schematic are pointing in the direction of conventional current flow. For example, when a diode is used to forward bias only, positive voltage is applied to the anode and negative voltage is applied to the cathode. In the conventional current flow theory, current will flow in the direction of the arrow. In the electron theory, the current flow must flow against the arrow. A common example of this use of conventional current flow theory is the electrical system of an automobile. Most automobiles today use a negative ground system, which means that the negative terminal of the battery is grounded. The positive terminal of the battery is considered to be the hot terminal, and it is generally assumed that current flow from hot terminal to ground. Now we're going to talk about how to test a diode. You can test a diode with an ohm meter. When the leads of an ohm meter are connected to a diode, the diode should show continuity in only one direction. For example, Assume that when the leads of an ohmmeter are connected to a diode, it shows continuity. If the leads are reversed, the ohmmeter should indicate an open circuit or no continuity. If the diode shows continuity in both directions, it means that it is shorted. No good. If the ohmmeter indicates no continuity in either direction, the diode is open. And that's not good either. The diode can be used to perform many jobs, but it is most commonly used in industry to construct a rectifier. A rectifier is a device that changes or converts AC voltage into DC voltage. The simplest type of rectifier is the half-wave rectifier. The half-wave rectifier can be constructed using only one diode. It gets its name from the fact that it will rectify only half of the AC waveform applied to it. When the voltage applied to the anode is positive, the diode is forward biased, and current flows through the diode, the load resistor, and back to the power supply. When the voltage applied to the anode is negative, the diode is reversed biased, and no current will flow. Since the diode allows current to flow through the load resistor in only one direction, the current is direct current or DC current. Diodes can be connected to produce full wave rectification, which means that both half waves of the AC current are made to flow in the same direction. A full-wave rectifier is better known as a bridge rectifier. In electronics applications, you will have, for example, trying to rectify the AC waveform, you will have 4 diodes in 2-2 configuration rectifying half wave, and that in turn will be a full wave rectification, and you will get a full DC rectification. Another application, for example, is in the industrial applications where we use 3-phase power. You will use a 6 diode configuration, and I will also show you a picture of that so you can have some understanding. But 3-phase and industrial power, it's another topic for another day. What is important is when the diodes is to be connected in a circuit, there must be a clear understanding of the markings, and that is why diodes are made of different case styles, so there are different methods of identifying the leads. Large stud, for example, often have a printed symbol on the case to show proper lead identification. Small plastic case diodes often have a line or band around one end of the case. This line or band represents the line in the front of the arrow on the schematic symbol of the diode. An ohmmeter can always be used to determine the proper lead identification. If the polarity of the ohmmeter leads is known, the positive lead of the ohmmeter must be connected to the anode to make the diode forward biased. The p-n junction diode has many uses. First and foremost, important probably is the use for rectification, but it can also be used for signal demodulation. Diodes are used to recover original modulation signals from AM or FM modulated waveforms. Clipping. It can limit voltages of the signal, which prevents them from exceeding certain thresholds or limits. Clamping. It can be used to clamp a waveform to a certain DC level by preventing it from going below. Current steering. Diodes are used in circuits for current steering, which ensures that the current flows in the specific direction under certain conditions. Diode logic circuits. They are used to implement basic logic functions such as OR, AND, and NOT gates. We're gonna discuss these gates in a future video. Voltage drops. Diodes are used to create fixed voltage drops in a circuit so that it can be used as voltage references. Other types of p-n junction diodes are used in voltage regulation, like Zener diodes. Well, that's another topic for another day. Thank you guys for watching again, and please, if you like my videos, like, share, and subscribe.